Alright, time for another draftphysics.com, debatephysics.com, also video presentation. So, third video in a series of videos attempting to solicit a counter-argument from physics in general, physicists. See if we can get one. And the argument is that even if you offer to pay them, you can't get them to address these arguments. And this is another one demonstrating kind of a paradox that exists in their theory of energy. Now, I could argue that one atom moving 1,000 miles an hour is the same energy as 1,000 atoms moving 1 mile an hour. That if I dissipate their energy into some volume, I'll end up with the same amount of mass moving. When I complete the exchange, when I take all of the energy of the one atom going 1,000 miles an hour, I'll end up essentially with 1,000 atoms going 1 mile an hour. And that it's the same heat they would produce. So if they would shoot a bullet into a joule tank that converts, in theory, all of the energy into a measurable heat, and then have the recoil of the gun do the same, they'll find that that's exactly the same amount of heat produced. So this really just has to do with the fact that you can apply energy in a different way, and it'll be more effective in doing some task. It won't be doing more of a task, it's just more effective for the thing you want to do. So you can put a point on an arrow, and it will in fact penetrate further. It doesn't mean it has more energy. It doesn't mean that it's going to do more work. And so physics hasn't fulfilled for that. They didn't, they figured out that yes, pointing the arrow does not mean the arrow has more joules of energy or more newtons of energy or more any quantity of energy. You're just applying it in a way that you're taking advantage of the application. And I would argue that speed is the same kind of distortion to the facts, in the sense that it will look something going fast, everything happens very fast. The motion's very fast, the movement's very fast, but it's very little compared to the motion of a big 1,000 atoms moving the 1 mile an hour. And so it can look like more energy. It'll drill a deeper hole. It'll do things like that because the energy is better conserved, in the sense that you don't lose as much to friction and all kinds of noise that would cause heat. And so it's more efficient in getting through something, but it isn't going to get through it by applying more pushing force. It's just going to apply it quicker in a smaller period of time and defeat the counter forces that might prevent it. So you're just going to basically break things. You're not going to crush them more. You're just going to take advantage that atoms have a structure and you can defeat the structure. So I've used a tipping point argument that you could have a stick and that's balanced, and you could throw 3 pieces of something at it. And the fact is that one piece hitting it won't tip it enough to tip over, and it'll rebalance. But if I throw the 3 things with a 2-second interval, I'll just wobble it and I'll never knock it over. But if I throw all 3 objects right behind each other, then the motion will be additive and the object will be tipped over. So you'll see a dramatic difference in the outcome, but it's exactly the same energy. And so this example kind of demonstrates that. So it's basically just taking 2 guns and putting them inside of each other with the same amount of charge, 1 unit of bullet, and firing it, or a gun and a bullet, or 2 bullets. And so I've just simplified that as using a zip gun, and you just have 1 kilogram bullets versus 1,000th or 1 gram bullets, and said basically the same 1,000 to 1 ratio of mass to velocity, and you get numbers that kind of demonstrate there's a problem. Houston, we have a problem because in each experiment you get a very different number for what your total amount of energy is if you use the kinetic energy theorem as a foundation. You know, the two 1 kilogram bullets, you only get 1 joule of energy out. With a kilogram and a gram bullet, you get 505 joules. Yeah, and 0.5 joules. And with two light objects, you'll end up with two 1 gram bullets. You'll end up with what they claim is 1,000 joules. Obviously, the same explosive cannot create these numbers because these joules represent watts and it also represents units of heat. So the explosive can't really be reduced to vastly different amounts of capacity to move matter, and so it doesn't make any sense. And if you look at the numbers, newtons, if you just go by momentum, you can see that it's always consistent. It's the same momentum produced in each experiment, indicating a much more reliable indicator of what was the actual energy of the explosive. And its actual energy is the 2 newtons. So it's pretty clear evidence that their theory has a defect in it. It violates Newton's third law. So all of kinetic energy theory, whenever you're applying force to different masses, Newton's third law doesn't apply at all, because simply in the gun is the typical example. This middle example is dramatic evidence, frankly, that you get 500 joules going one way and 0.5 joules going the other way by their theory. 1,000 to 1 difference in the equal, what's supposed to be an equal and opposite reaction. So clearly it doesn't obey the third law, and that should be recognized as something that needs to be explained or accounted for, because there's not much use in talking about the third law if it doesn't apply to any circumstance where you're applying energy to two different masses. So it never applies in most cases, because in most cases the two things interacting are not going to be of the same mass. So so it's a simple enough argument. I think dramatic evidence that it's much that there's darn good reason to believe momentum is the only thing that moves things in the universe, that momentum does directly convert to heat, that it will always come out that way, that it is the elemental function, that the universe is just made out of masses moving, and you can change, big M, little v into big V, little m. 1,000 atoms going 1 mile an hour is in fact the same capacity to push on the universe that one atom going 1,000 miles is. It will reduce to exactly the same thing, not things that are 1,000 times difference, not something 1 joule versus 1,000 joules. If you're doing a test to measure how much energy you're getting, and you're getting that kind of difference, I'd argue that it's kind of obvious it's not going to be consistent with any Newtonian physics. That's about all I can say. I mean, there's so many other examples, okay, that I will go through in these videos, but there's darn good reason to demand better evidence from physics. And they haven't done any of these experiments. Like I said, the Joule tank was invented over 100 years ago, and they haven't used one for 100 years to test anything. And it's a pretty reliable way to reduce something that has MV into heat and to collect what it's capable of producing as motion in the universe. Alright, so that's all. I'll call it a video, and we'll see what happens. See if somebody can make a counter argument that coming up with these very different numbers for the same explosion somehow does make sense.